Right, I've got a little bit of core maths, further maths, integration. We've got to integrate RCOSH 5x between 3/5 and a quarter. CFB3 paper, International A-Level, question 8, June 2023. The question actually sort of said show that it's equal to 3/20 minus 2 root 2 over 5 plus the ln of p plus q root 2 to the power of k minus a quarter ln r. And I've got to find out what I missed. So anyway, so we look at the formula book, and there's no sign of RCOSH. What are we going to do? Well, take some deep breaths and think some happy thoughts.
Just sending you some good vibes.
It's all about the good vibes. So ditch the formula book for the integration section and look at the differentiation section in the end. Yeah, we're going to integrate by differentiating. It tells us what RCOSH differentiated is 1 over the square root of x squared minus 1. And then we're going to do it by parts with the integration by parts formula by shoving in a 1 in there, which is going to be our dv over dx. So the u is the RCOSH 5x, and I say that 1 is the dv over dx, and we need v, of course. So if dv over dx is 1, the v is equal to x, and if the u is RCOSH 5x, we've got to differentiate that. RCOSH differentiate is 1 over x squared, square root of x squared minus 1, but it's 5x, of course, so we need to change the x into a 5x. And then, because the chain rule, we need to multiply by the 5x differentiated, so I multiply by 5. So we've actually got 5 over the square root of 25x squared minus 1. So we shove that into our formula. uv, use RCOSH 5x, multiplied by the v, which is an x, minus the integral of v du, v is x, and then the du is that 5 over the square root of 25x squared minus 1. So it looks like that. We'll sort the x RCOSH 5x out first. We put it into that form there, the ln, it's going to give us that ln p plus q root to the k. Because when we do RCOSH, it's the ln of x plus the square of x squared minus 1. So we've got, when we stick 3/5 in, we get 3/5 RCOSH 3. And when we put a quarter in, of a quarter RCOSH 5 quarters, putting the 3 into our RCOSH ln formula, 3 plus 3 square root of 3 squared minus 1. And then we're putting a quarter in. It looks like that. The first bit, we'll see the 3/5 up the top. I don't know why on earth they didn't leave the 3/5 in front of the ln, but for us to be annoying, I suppose. And then the other bit, well, I need to work out 5 quarters plus the square root of 5 quarters squared minus 1. 5 quarters squared is 25 over 16. 1 is 16 sixteenths. So that gives us 9 sixteenths. The square root of that is 3 quarters. 5 quarters, 3 quarters, 8 quarters, which is 2. So that's a quarter ln 2. So that's what the r is. So I've now got the p, the q, the k, and the r. I've just got to show the other bit comes to 3/20 minus 2 root 2 over 5. And it's this here. Now, there's one way of doing it. You can do it with the COSH substitution, because that's what the formula book is sort of suggesting. That integral gives you RCOSH. So it looks like we're going to do an x to COSH substitution. But I've got 25x squared, so I need that to be 5x there. So I want the 25x squared to be COSH squared. And then so subbing those in, the 5x on the top is just COSH u. 25x squared on the bottom, well, that's COSH squared. And I've got minus 1 square rooted. I need to sort the dx out, of course, and differentiate both sides of that in terms of u. 5 dx over du is sine u. Or I can write it like this: the dx is a 5th sine u du. So that's the substitution done. Looking at the formula book, COSH squared is minus sine squared is equal to 1. So COSH squared minus 1 is sine squared. Square root of sine squared is just sine, so I can cancel out the sines there, and I've just got a 5th of COSH u, and of course COSH and sine integrated gives you sine and cos respectively. No worry about any negatives. Don't really need a plus C, of course, because I've got limits, and we could change the limits into U limits. So if the x was 3/5, the cos u is 3, so use the r cos 3 and put in a quarter in. I get cos u is at 5/4, but I'm not going to do that. What we're going to do, we're going to use our hyperbolic functions identities and say that sine u is the square root of cos squared minus 1. And of course that's 25x squared minus 1, and that's what 5x over the square root of 25x squared minus 1 integrated is. And then stick the limits in there. But,
you don't want to do it like that.
Well, we're not going to do it like that because there's a better way of doing this. We're going to go with what do I differentiate to get that. So I want to differentiate something and have 25x squared minus 1 to the power of minus a half because I've got the square root on the bottom. So what I want to do is differentiate 25x squared minus 1 square rooted, or 25x squared minus 1 to the power of a half. When I do differentiate that, the half will go in front. I'll get that bracket at the minus half. Then I need to multiply by 50x. So that's going to be 25x over the square root of 25x squared. So nearly right. It's just I've got 5 times too much. So when I do the integral, it's going to give me the square root of 25x squared minus 1, but I need to put a fifth in front. I'm going to now stick the limits in. So 25 3/5 squared minus 1 square rooted, put a quarter in, and then that first one gives me root 800 because I've got 9 minus 1, and then I've got 25 over 16 minus 16 over 16, which 9 over 16 3/4, and it gives me 2 over 5 root 2 minus 3 over 20. So the whole thing then, I worked out the x r cos 5x with the limits in, and it was that's the second part of the expression, and the other one gives me the first part, but I need to, I'm taking it away, so it gives me that, and I've left it in that order because I like the LNs at the start.